So welcome back. Again, test Friday. Quick turnaround, but there's really only one lesson. Tomorrow is more practice with word problems, but not really even difficult word problems, just pictures. Block days review, Fridays with test. I'll say this again later, but just while we're here looking at this, today's assignment is worksheet 1 and 2, but the odds. So half of 2 worksheets is the same as all of 1 worksheet, right? This is a little bit of math for you. And then even on block day, we'll just say the odds on the review. So try to pare it back a little bit. All right, law of sines and law of cosines. Whoops, put that where you can read it. There we go. Law of sines and law of cosines. Thank you. Before we do Roman numeral 1, these are for solving triangles. And until now, until this unit, really we could only solve right triangles. Right? A squared plus b squared equals c squared, SOHCAHTOA, and you could solve right triangles. With law of sines and law of cosines, we can solve all triangles. They don't have to be right triangles. So that's the big deal with these. You can solve goofy looking triangles. They do not have to be right triangles. So Roman numeral 1, law of sines. Let's draw some random looking triangle. It does not matter what your triangle looks like because law of sines works for all triangles. So there's any triangle you like, triangle ABC. Across from across from angle A is side A. Across from angle B is side B, and across from angle C is side C. So that's kind of an important part that we sometimes breeze by that students get messed up on later, is that the angles and sides of the same name have to be across from each other. A is across from A, B is across from B, C is across from C. Okay, here's the formula. Sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over side C. So that maybe feels weird because it's like a 3-sided equation. So like how do you don't ever use all 3 at once. Use 2 pieces at a time. And as we get going, it'll be easy to know which 2 pieces to use. Basically, you'll use, if you know both pieces, if you know A and A, then definitely use that. And then if you know part of one of the others, use the other. So it'll be easy to figure out which 2 to use once we get going. Now, big picture though, we have to know whether to use law of sines or law of cosines. The good news on the front end is if you try to use the one that doesn't work, it's not that you'll get a wrong answer, it's just you won't have enough information. So if you pick the wrong one, you'll figure it out pretty quick. But let's assume we don't want to even pick wrong. So let's talk for a minute about how to pick or how to know when to use law of sines and when to use the law of cosines. Like how to know which set of formulas to use. I'm going to put these abbreviations down, and it may bring back rough memories for you. Side, 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 Side angle side. Do you remember when you used those before?
Geometry.
Geometry, okay. Do you remember more specifically, like when in geometry you used them? Okay, that's the two words I'm looking for proofs of congruency, right? Because if two triangles had the same SSS, then they were congruent. Or if they had the same SAS, they were congruent. We're not doing proofs. We're not doing congruency. This is just about the information you have. If you have three sides, then you will use law of cosines. If you have side angle side, you would use law of cosines. If you have angle side angle, you would use law of sines. If you have angle angle side, you would use law of sines. Do you remember the one case you're not allowed to use? Some of you do because you're smiling because, right, it's a bad word, right? Angles, or no, I have to say it backwards so I don't have to write the bad word. Angle side angle, right? You're not allowed to use that one. Do you remember that? That's not a congruency theorem. It doesn't work. And we're not really going to go into it, and we're not going to use it because it's the ambiguous case. So it is, in geometry you don't use it, and basically in PreCal you don't use it either because it's a pain. We're not going to worry about it. All right, so let's do an example with law of sines. By the way, you will definitely need a calculator, so I'm going to just hit pause. You go get a calculator. All right, so now that you've got your calculator, let's say angle B equals 31 degrees, angle C equals 20 degrees, side C equals 210, and the instructions will say something like solve the triangle. You know what solve the triangle means? Find everything else. Yeah, it's rather than having to spell it out each time, solve the triangle just means find all the missing sides and missing angles. Thoughts on what we should do first? It's our very first one, so let's draw a picture. That will help us visualize the problem and help us know what we know and what we don't know. It doesn't really matter what your triangle looks like, or even where you label angles A, B, and C. So this is probably not to scale, but that's fine. It doesn't really matter. What does matter is that side C is across from angle C, so I need 210 to be across from angle C. I need the C's across from each other. All right, well, clearly this is a law of sines problem because we're in the law of sines section, but if you didn't know which one to use, let's see, this information is angle, angle, side, so that's law of sines. Maybe even a better way to say when to use law of sines is if you have information across from each other. If you have two pieces of information across from each other, then you'll use law of sines. Now, before we get too far ahead of ourselves here, before we even do that, is there something you can find, part of the triangle you can find without even thinking about law of sines? Angle A. Because geometry experts, how are you going to find angle A?
You said when there's information across from each other, it's not law of sines.
Yes. If you have an angle side pair across from each other, it will be law of sines. So 180 minus 20 minus 31 is 129. Okay, so we got angle A. That was easy. That wasn't really even law of sines. I'm going to label my missing sides, A and B. And again, knowing an angle side pair is the starting point for law of sines. So sine of 20 over 210 equals, and then you could pick either of the other pairs, right? Because you don't know side A and you don't know side B, so it doesn't matter. I guess let's just go alphabetical order here and do sine of 129 over side A. Now this is just an algebra problem. Cross multiply would probably be the easiest way to go. So A sine 20 equals 210 sine 129. Ooh. What caused my ooh there? What do I need to be careful about? Do you know? Radians versus degrees. So which one do I need to be in? Degrees. This is 129 degrees. So switch to degrees. All right, 210. How do you turn to degrees? Mode. (210) sine 129 divided by sine of 20. And there's my side A. $477.167. I'm going to go 3 decimal places because that's what calculus requires, the AP calculus class. All right, so I've got side A. You don't have to label it, but some people like to label the triangle because then it's kind of easy to keep up with what you know and what you don't know. Okay, any idea on what we could do next? What's the last thing to find? Side B. So let's do another pairing here. And I'm going to stick with my original information. So I could use the A stuff since I know it both. So I know side and angle. But side A is a weird number, and that was a calculated number. So just in case I mess that up, I'm going to go back to my original information. Sine 20 over 210 equals sine 31 over B. Again, cross multiply. And again, divide. Sine 31 divided by sine 20, 316.233. So that's law of sines. Not really that hard. Angles. Find an angle side pair that you know. Start with that. And then set it equal to one of the others, and then set it equal to the other one. There is a little bit of a check. It's not a foolproof check, but it's a little bit of a check. When you get to the end, the smallest side should be across from the smallest angle. And the largest side should sort of pair up with the largest angle. So that's a really quick and easy check when you get done. It doesn't guarantee you got it right, but if this isn't true, then you probably just messed up something in the calculator. Let's check here. So side A is the biggest side, or excuse me, well, that's true too. Angle A is the biggest angle, side A is the biggest side, those go together. Angle C is the smallest angle, side C is the smallest side, so I feel pretty good about my answer. Again, it's not a guaranteed check, but it's a little bit of a check to make sure you didn't mess something up too bad. That's the law of sines. Pretty simple. I would say the first question on the test rearranges the law of sines a couple different ways. So be careful. Make sure you could flip those over. So you could say A over sine of A equals B over sine of B. Right? That's the same thing. If you really wanted to get crazy, you could say A sine of B equals B sine of A. But those aren't new equations. That's just rearranging what you already have. So what you need to know is the easy formulation, and then a little bit of algebra can move things around if you need it. Questions on any of that? Law of sines. That's the easy one, especially since we don't do ambiguous case. All right, Roman numeral 2, law of cosines. This would be if you have side, 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 or side, angle, side. Or if you don't have an angle side pair. That's probably the easiest way to phrase it. If law of sines won't work, like there's no angle side pair that you know, then it's going to be law of cosines. So again, some people think about side, 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 angle, that stuff. Other people just look for law of sines. If it's there, use it. If it's not there, then it's going to be law of cosines. Let's again start with any random triangle you like, as long as side A is across from A, side B is across from B, side C is across from C. Law of cosines it's harder algebra-wise because there's more stuff going on, but the formula starts out looking very familiar. C squared equals, what does C squared usually equal in geometry? And so it starts out as A squared plus B squared. That's not all of it though. When does A squared plus B squared equal C squared? Or when are we allowed to use that formula? That's for right triangles. But now we want to use for all triangles, so we have this extra term on the end. Minus 2AB cosine of angle C. So it sort of starts with the Pythagorean theorem, but then it gets a lot more complicated because it's not just for right triangles. And probably the big thing to note is that the angle you use is the angle that's on the other side of the equation. But that sort of fits because angles and sides are always across from each other in the triangle, and they're across from each other in the equation. Now, I guess maybe another tricky part of law of cosines is when we do A squared plus B squared equals C squared, C has to be the hypotenuse. right? We don't even say that anymore. You just kind of know it. But we don't even have a hypotenuse anymore. So we're not really restricted on who's over here. We could just as easily say b squared equals, you want to guess what's on the other side of the equation? So it would just be like if we shuffled up who's labeled what? A squared plus c squared. Minus 2, and then these two sides, a and c, cosine of the angle across from it, cosine of angle b. Again, the angle you use is across from in the triangle and in the equation, across from the other side. And then there's one more formulation. A squared equals the other two sides, b squared plus c squared, minus 2, those two sides, b and c, cosine of the angle across from a. So law of cosines is kind of 3 equations, but it's kind of just one. Just be very careful about who's a, b, and c. All right, example 1. A is 16, or side A is 16 because it's lowercase. Side B, lowercase b, is 10. And angle uppercase C is 110 degrees. Let's draw a picture. Again, you can use the angles to sort of try to draw it to scale if you want to, but it doesn't really matter. 110 is bigger than 90, so if I have an angle that's bigger than 90, maybe I should make that angle C. But again, drawing it to scale doesn't really matter. In fact, it might mess up who gets labeled what. Right. Side A across from angle A, side B across from angle B, and I know angle C. Okay, big picture, we know we're in the law of cosine section, so obviously this is going to be a law of cosines example. But if this problem wasn't tucked into the law of cosines notes, how would you know that it's a law of cosines problem? Do you know? Okay, there's 2 answers. One answer is it's side angle side, so it's law of cosines. The other answer, anybody know the other answer? Because law of sines won't work. There's not a side angle pair to use, so it must not be law of sines, right? I don't have C and C, or A and A, or B and B, so therefore I guess it's law of cosines, and that's perfectly okay. That's a good way to see the problem. All right, so it's got to be law of cosines. But I've got 3 different formulations of the law of cosines, and which one should I use? Why c squared? Yes, because we don't have c. That's a good answer. And we have angle c. So like the combination of not knowing c but knowing angle c means, yeah, we should probably use that first formulation, or the first formula. C squared equals a squared plus b squared minus 2 times these two sides, cosine of the angle across. Okay, so let's start filling stuff in. 16 squared plus 10 squared minus 2 times 16 times 10 times cosine of 110. This is just a calculator problem at this point. Be careful putting it in, but it's just a calculator. 16 squared plus 10 squared minus 2 times 16 times 10 times cosine of 110. $465? That doesn't seem right. I got to square root it. So just like Pythagorean theorem, you don't do this anymore, but when you first started, some of you would forget to square root it. Same thing here. But if you're paying attention, side C being 465 doesn't really make sense for this problem. So hopefully you would catch that and then realize, yeah, you just need to square root that to find side C. 21.574. Don't have to label it on the picture. Some people like to label the picture because it helps them keep track of what they know and what they don't know, but not necessary. All right, we still need to find angle A and angle B. All right, here is the tricky part, or here's where being smart might get you in trouble. How do you want to find angle A and angle B? I'm trying to bait you into the wrong. Right. So, okay, the 180 thing won't work yet because I don't know either one of them. So I do like the 180, and if I can find one of them, I can use the 180 minus the others. So yes, we'll keep that in mind, but not yet. Joseph, you said law of sines, knowing I'm trying to bait you in the wrong answer here. Why did you say law of sines?
Because we have side C and angle C.
Yeah, it's like, oh, we've got a side angle pair. Can I use law of sines now? And the answer is maybe, but you might get the wrong answer. So if you start a problem with law of cosines, you just need to stay with law of cosines. It's a long reason why. It has to do with the ambiguous case. It's complicated. The short answer is, if you start a problem with law of cosines, stick with law of cosines. So that means I need to write another law of cosines for either A or B. I guess we'll do A. Now, I know side A. I'm looking for angle A. So I'm going to put those two in first. I'm going to use the A formulation of law of cosines, which means my other two sides are B and C. So let's see, 16 squared equals 10 squared plus C squared. That's kind of annoying, but it is in your calculator, so that's not too bad. Okay, now for the fun part, meaning the algebra part. I want to get cosine of angle A by itself. So let's subtract over the 10 squared and the 21.574 squared. In fact, maybe we better slow down and just do that. But I hope a bunch of you know what we're going to do next. I'll probably stop writing this step after this problem. All right, so subtract over the 10 squared, subtract over the b squared and the c squared. Still trying to get cosine of angle A by itself. So what should we do next to get cosine of angle A by itself? This is the most missed part of the whole unit right here, is this algebra step. How do I want to get those three things to the other side? Yes, divide them over. I'm not going to multiply them yet. I'm just going to let the calculator do that. But yes, divide them over. You want to guess what the wrong answer is that people do? Well, or add, because, oh, look, it's a minus sign, so I'll add them over. Like, no, no, no. Those are being multiplied, so let's undo the multiplying with dividing. Now, because I'm showing steps, this is a lot of writing. Once we get rolling, you're not going to show all these steps. You're going to do a lot of it in your calculator. All right, that looks ugly. I'm nervous about putting that in my calculator, so it might be a good idea to do the fraction bar thing. Alpha F1 or alpha Y equals. That makes it real clear who's in the top and who's in the bottom. And if you want to get fancy, you could do answer squared like that. That way you don't have to type C in. Divided by -2 times 10 times that answer again. Okay, that's what cosine of angle A equals. How do I undo the cosine? Like somebody took a cosine and got that for an answer. How do I undo that to get back to the angle? Pardon? Yeah, inverse cosine. So cosine of A equals that, so I need to do inverse cosine to undo that. So angle A, 44.179. So law of cosines is harder because the algebra is, it's not hard, it's just a lot of steps, and you've got to remember to do inverse cosine. Trying to move around to see what's left here. Again, you don't have to label the picture, but when you label the picture, I think it's really easy to see what's left, and even maybe what we need to do to find what's left. So angle B is the only thing left. There are two options to finding angle B. One of the options is to do the law of cosines with b squared equals all of the other stuff. But what's the easier option for finding angle B? Even easier than law of sines. Subtract from 180. So angle B is 180 minus the other two. .821. Question? All right, we need to do one more law of cosines example because there's one more. Actually, let's just peek behind the curtain. Here's why. That was an SAS problem. We need to look at an SSS problem because they work a little bit differently. So let's say side M, we'll get away from the ABC stuff, equals 20, side L equals 15, and side B equals 8.3. I don't know why I picked MLB. Maybe baseball's on the mind. It's starting soon. So we got triangle MLB. Side M is 20. Side L is 15. And side B is 8.3. So very clearly an SSS problem, which if you memorize who goes with what, that means law of cosines. But what's maybe the easier way to know this is a law of cosines problem? It's not a sines problem because there's not an angle side pair to use. So Law of sines is out. It's got to be law of cosines. And I've got to find an angle. So which angle would you like to find? Doesn't really matter. We just need to pick one. M it is. So if I want to find angle M, that means I need to use the formula that has angle M in it, which means that's the one that has M squared on the other side. So I'd really like you to get away from memorizing all three formulas. That's a little bit silly. Know that the angle and side have to be across from each other, and then I'll use the other two sides in here, so L and B, L squared plus B squared, minus 2 times those two sides, L and B, times cosine of M. Alright, algebra. I'm going to press pause. You see if you can find angle M from there. So you got a couple of algebra steps and then an inverse cosine at the end. Okay, just move things around. Go to the calculator. A lot of you aren't going to show any of that stuff. Like, it'd be nice if you'd show that, so at least I know what you're working with. But after that, most of you, maybe not most, many of you anyway, are going to go to the calculator, and the next thing I'm going to see is angle M equals 115.223, and that's fine. I don't need to see everything. So I know angle M. Notice my lazy way of acknowledging I know angle M without writing everything. Just, yep, I got it, check. Now I need to find angle L or angle B. So I have to do the same thing again. So just so we're all on the same page, shall we find angle L or angle B? L it is. So this time I'm doing even less. You find angle L. So there's angle L. And that only leaves one more. That leaves angle B to find. We could do this whole thing again with angle B, or what would be the better option for finding angle B? Angle B is 180 minus the other two. All right, today's assignment, worksheet 1, odds, that's law of sines. Worksheet 2, odds, that's law of cosines. So we sort of squeezed 2 lessons into one, but it's really not that big of a deal. Tomorrow we'll have picture problems. Wednesday we'll review. Friday we'll test. So yes, it's a quick turnaround. On the other hand, you've seen everything that's on the test.